Look at the answers to the evens, starting with 86. Number 86, the radius of the circle is 2,150 meters. 88, part A, the normal force is 8,240 newtons. Part B, the frictional force is 1,550 newtons. And part C, the minimum coefficient of friction is 0.188. And then 92. The value of B is 3.27 times 10 to the negative 9th power. And the units on that are kilograms per second. 93 and 95 were in the back. All right, 94? 94, thank you. 94, part A. The drag force is 589 newtons. And part B, the value of B would be 0.942 kilograms per meter. All right, I want to go over anything. Yes, Vincent. Vincent. 88. Okay, let's look at 88. 88 was a long problem. It took me like a page and a half to do. So let's see. Okay. So 88 says that we have a curve with a radius of 150 meters, which is banked at an angle of 10 degrees. An 800 kilogram car is negotiating the turn at 85 kilometers per hour without skidding. All right, before I do anything else, I know I have to kind of make a free body diagram or a sketch of the situation. So here is the car on that turn. I know that the radius of the turn, they tell me, is 150 meters. I know that the angle of the embankment is 10 degrees. I know that the mass of the car is 800 kilograms. And I know the speed, but I have to do a conversion. We don't deal with kilometers per hour. 85 kilometers per hour would be the same as, well, 1 hour is 3,600 seconds. And the prefix kilo is equivalent to 10 to the third power. So we're going to just work out that math. And when you work that through, we end up with a speed with the 3 sig figs the textbook wants us to use of 23.6 meters per second. Okay, now in order to work on this question, the first thing I want to know is the normal force, then I want the friction force and the coefficient of static friction. When I did it, I actually found the static friction force first. Doesn't matter which one you come up with. But anyway, here's a free body diagram. Normal force perpendicular to the surface. The weight of the car straight down. And you have to pick a direction in which the static friction force might act. Typically, when you're going around an embanked turn, a turn that's on an angled road like this, if you're going too slow, the car will slide down. If you're going too fast, it will try to slide out. We don't want it to slide either way. So you have to pick a direction in which you want the static friction force to act on those tires so the car doesn't slide up or down. I'm going to just pick down the plane. If I pick the direction incorrectly, I'll just end up with negative answers. All right. That's it. Now, which way is the car going to accelerate? It's going to accelerate inward on the turn. It's going around a circle. So it's going to go inward. It's not going to accelerate parallel to the plane. This is why it's on an embankment. The embankment is there to try to reduce dependency on friction. So when I look at my free body diagram, remember I need all my axes parallel and perpendicular to that acceleration. I see that there are two forces which do not lie on the X or the Y axes, which are parallel and perpendicular to the acceleration. That's the normal force and the friction force. So those are the forces we're going to break into components. They show you how to do that in the textbook for these embankment questions. So let's redraw this. Here's my X and Y axes. Here's the embankment. And I know the weight is going to stay downward. I probably shouldn't have done it quite like that. Let me redraw this. I don't like that they're all solid. It's hard. It'll be hard enough to see. All right, so here's that embankment. Let's say that's the car on it. We know we want everything perpendicular, up and down, and parallel, horizontal. So the weight is going to stay because it's on that axis. The normal force would be broken up since it's between the up and the right axes. We would have a component of the normal force acting up. I'm going to call that the Y component, and a component of the normal force acting in. I'm going to call that the X component. Since the force of static friction is between the down and the right axes, we're going to have a component of the static friction acting in the X direction and a component of the static friction force acting down in the Y direction. Now we know since the acceleration is to the right, that the forces in the vertical direction must sum to 0. What that means is that the normal force in the Y direction acting up has to balance out the two forces which are acting downward. That is gravity and the force of static friction, Fs in the Y direction. In the X direction, those forces are the net force, which means that the normal force in the X and the force of static friction's X component would have to equal ma. Now the acceleration is a centripetal acceleration because it's moving in a circle. So that can be found by doing v squared over r for the a. Is everyone with me so far? Yes? Okay. So now let's talk about how we get the X and Y components of both the normal force and the frictional force. This is going to involve a little bit of geometry. Okay. Matt, you got a question?
Yeah. So why
because the object is not accelerating parallel to the plane. As a general rule, you must always look at which way an object is accelerating and use axes which are parallel and perpendicular to the acceleration's direction. You cannot look at an incline anymore and just say, oh, parallel perpendicular components of weight. That would only be true if this object were accelerating parallel to the plane, which it's not. It's moving in a circle, which is parallel to the ground, not to the incline. So the acceleration is inward, which means I need axes parallel and perpendicular to the acceleration. That's always how it's done. In Regents, we simplified it because you never had any of these embankments, which we did you a disservice there if you were coming into this class, because now you got it. Oh, incline, break up weight. No, that's not how it's done. Okay, but we have to simplify that because not everybody in Regents is able to understand this part of that. Okay, so let's now talk about a little bit of geometry. We know the angle of the embankment is 10 degrees. That means the angle here in the picture is what? What is that angle right there? No. This angle here is not 80 degrees. It's 10 because these are alternate interior angles. They are congruent. This here is 10 degrees. What is the angle here? That one's 80 because the normal force and the frictional force are perpendicular to each other. So if this is 10, that angle there is the complement of 10, which means that normal force is 80 degrees from the horizontal. Okay? Everybody with me? All right, so let's now talk about the components of the frictional force, which are X and Y. The X component would be adjacent to that 10-degree angle. It's on the side here, which means that the X component of the friction would be that force of static friction times the cosine of 10 degrees. The Y component, up and down, would be opposite this 10-degree angle, which means the Y component of the friction would be the frictional force times the sine of 10 degrees. Everybody with me? All right. Let's now do the same type of thing for the components of the normal force. Here is that angle. The X side here is adjacent to that 80-degree angle, which means the X side is going to use the cosine of 80 degrees. The Y side, up and down, is opposite 80 degrees. So that means this would be the normal force times the sine of 80 degrees. Everybody with me? Yes, so far so good. Okay, so let's do some replacements here. Let's start with our Y equation. The normal force in the Y is Fn sine 80 degrees. Fg is mg. The force of static friction, I'm just going to leave it in the Y direction, is Ffs times the sine of 10 degrees. Right now, there are two things I do not know. I do not know the normal, and I do not know the frictional force. Do I know the value of m? I do. Do I know the value of g? Absolutely. Okay, so there's only two things I don't know right now. If there's two things I don't know, how many equations do I need to solve? Two equations for two unknowns. So let's now use this as our second equation. The normal force in the x direction will be the normal force times the cosine of 80 degrees. The frictional force in the x direction is the frictional force times the cosine of 10 degrees. Notice right now, I can figure out this because I know the value of m, I know the value of v, I know the value of r, and I have here my two unknowns. So I have two equations, two unknowns. Now I just need to solve. So I don't know. Which one do I want to solve first? I want to solve for the normal force first, right? That's what it said. So I have to eliminate the static friction force. So let me solve this one for the force of static friction. That's going to be Fn sine 80 degrees minus mg all over the sine of 10 degrees. What do I do with that now? I take that and I plug that in there for the force of static friction to eliminate that variable. So this is the normal force times the cosine of 80 degrees plus, let's replace that static friction force with Fn sine 80 degrees minus mg all over the sine of 10 degrees. We're going to multiply all of that by the cosine of 10 degrees, and that's equal to mv squared over r. Notice now the only unknown variable is Fn. The only unknown variable is Fn. So what I'm going to do now is distribute this cosine of 10 degrees. Following order of operations. So that would be Fn sine 80 degrees, cosine 10 degrees. Actually, let's do this. If I pull out the sine of 10 and put it here, that can convert to a tangent function, right? Or cotan, or divide by tan. So this would be the same thing as Fn sine 80 degrees minus mg all over the tangent of 80 degrees. No, the tangent of 10 degrees, excuse me. 10. Is everybody with me? Did I lose anybody? No, not yet. Okay, good. Hopefully I'm not going to. Now let me distribute that tan function. Now, why did I do that? Because I want to factor out the FNs here so I can solve for FN. So this would be Fn cosine 80 degrees plus Fn times the sine of 80 degrees over the tangent of 10 degrees equals mv squared over r plus mg over the tan of 10 degrees. Let me factor out the normal force here on the left. So that's the normal force times the cosine of 80 degrees plus the sine of 80 degrees over the tangent of 10 degrees is equal to mv squared over r plus mg over the tan of 10 degrees. Lots of algebra. Let's keep going. So to solve for the normal force, I'm going to do mv squared over r plus mg over the tan of 10 degrees all over the cosine of 80 degrees plus the sine of 80 degrees over the tangent of 10 degrees. Did I make any mistakes? Mo, you're shaking your head. Yes. Did I make a mistake? No. You're with me. Okay, so now I can plug numbers in. What is the mass? I know the mass is 800 kilograms. The speed is 23.6 meters per second, which must get squared. We're going to divide by the radius of the circle, which is 150 meters, plus 800 kilograms times 9.8 meter per second squared all over the tangent of 10 degrees. Then I have to divide this whole thing by the cosine of 80 degrees plus the sine of 80 degrees over the tangent of 10 degrees. Now it's a calculator problem. Can you do it right on your calculator? So let's try it. You don't want to be trying this for the first time on a test. And when I work it through with 3 sig figs, I get 8,240 newtons, which I think was the answer I gave you. I'll make sure you can all get that correct on your calculator. Now, part B wants the static friction force. So if I look back at the equation I derived for the static friction force, it was that normal force times the sine of 80 degrees minus mg all over the sine of 10 degrees. So now I'm just going to plug in 8,240 newtons times the sine of 80 degrees minus 800 kilograms times 9.8 meter per second squared all over the sine of 10 degrees. And I'm just going to plug that in. And that gives me an answer of just 1,000, slightly different than what I told you, 1,580 newtons. Now, part C wants the coefficient of friction. So remember that forces of friction are coefficients of friction times normal force. So this is the easy part. So I'm going to take 1,580 newtons and divide by 8,240 newtons, and that will tell me what this coefficient of friction is. And actually, I got a slightly different answer than what I gave you. 191. No, 192. And that's how this question is done. Matt?
When you're talking about normal force, the equation v squared over r, like that r, isn't.
That's the radius of the circle that you're moving in, which they told you in the question was 150 meters.
Isn't that like the thing?
That's not the length of the embankment. That is the actual radius of the turn. So if I were to draw a picture of this, here's the embankment. The center of the turn is here. The car is up here. The radius is this horizontal distance. They did not tell you the length of the embankment. They said the radius of the turn. The radius of the curve. That's that angle right there. Okay. Olivia? Yes. Try to save some paper here. All right. Question 92. Says a small pollution particle settles toward the earth in still air with a terminal speed of 0.3 millimeters per second. The particle has a mass of 10 to the negative 10 grams and a drag force in the form of BV. All right, so here is that particle. The drag force is in the form of BV. And the other force that's going to oppose it is its weight. What is the value of B? Okay, so if I do this at the terminal speed, these two forces are going to balance each other. So at a terminal speed, we always know that there is no acceleration, which means that the sum of the forces on that diagram must be 0. In other words, the drag force at the terminal speed is going to balance the weight of this particle. So B times VT would have to equal mg. So actually, let me get rid of this T on the free body diagram because it's not always the terminal speed. It's whatever speed you have. Only at the terminal speed will there be no acceleration. Okay, so I want you to solve this for the value of B. That means you're going to do mg over the terminal speed. The mass was given to us as 10 to the negative 10 grams. I need it to be in kilograms. So 10 to the negative 10 grams I have to multiply by kilo and divide by 10 to the third power. G is 9.8 meter per second squared. Now, the terminal speed is given as 0.3 millimeters per second. We need it in meters per second. So we're going to cancel the milli and replace it with its power of 10, 10 to the negative 3. So the millis will cancel. Now I can go to my calculator, plug it in, and when you do that in question 92, you'll get an answer with 3 sig figs of 3.27 times 10 to the negative 9. Notice that the units, this meter and that meter, are going to cancel. This second is going to cancel that square, which means I'm left with kilograms over that second. And that's how we get that answer in 92. Anything else you would like to ask about on this homework? Yes, Jerry? 86. All right, 86 talks about this airplane that's on another banked turn, flying in a horizontal circle at a speed of 480 kilometers per hour. We don't like kilometers per hour. We'll change that in a minute. Banked for this turn, the wings of the plane are at an angle of 40 degrees from the horizontal. Assume that a lift force acts perpendicular to the wings. The lift is like the normal force. There's no surface that the plane is on. You could think of the air as that surface. So the normal force is the force of lift. I want to know what is the radius of this turn to keep it there. All right, so if I start with a free body diagram of the airplane on the embankment, there's the airplane. I know that we have this lift force and the weight. That's it, just the lift and the weight. We know this angle here is 40 degrees, and since it's going to accelerate inward towards the center of the turn, I need all my forces resolved into vertical components and horizontal components. Which means that if I were to redo that free body diagram, there's the airplane. I'm going to have a lift force component which points up. That is the lift in the Y direction. I would have a lift component in the X direction to the right, and the force of gravity pulling it down. Since this plane does not accelerate up or down, we know that the forces in the Y direction will sum to 0, which means that the force of lift in the Y is balancing the weight of the plane. And in the X direction, we have a centripetal force, which is provided by the lift's X component. And that acceleration is v squared over r because it's centripetal. So what I'm going to do is now replace the lift. I know if this angle here is 40, that angle is 40, because those are alternate interior angles, which means this angle right here is how much? 50, because the lift and the wings of the plane are perpendicular, so that must be 50 degrees, which means that the Y component of the lift is the lift force times the sine of 50 degrees, and the X component would be the lift force times the cosine of 50 degrees. So let me make some changes. The lift force in the Y here would be the lift times the sine of 50 degrees. that has to equal mg. The lift in the x is the lift force times the cosine of 50 degrees, which equals mv squared over r. Now, what I'm going to do is take this equation in the y direction and solve it for the lift, which is mg over the sine of 50 degrees. I'm going to do that so I can plug it into the other equation for the lift, which means I can replace the lift with mg over the sine of 50 degrees. And do you see why I want to do that? What's going to cancel out now? Look at this equation here. What's going to cancel out? The mass. Good thing, because I do not know the mass of the plane. So let's work this through. The left side is the same as g over the tangent of 50 degrees. I want you to solve that for r. So r becomes v squared tan 50 degrees over g. So r is, we got to change 480 kilometers per hour to meters per second. Kilo is 10 to the third power. 1 hour is 3,600 seconds. So if I do the math on that quickly, I find that the speed is 133 meters per second with the 3 sig figs. So that's 133 meters per second squared times the tan of 50 degrees over 9.8 meter per second squared. Go to your calculator, plug that in. 133 squared divided or times tan 50 divided by 9.8 gives me an answer with 3 sig figs of 2,150 meters. Okay. Anything else? I got 3 minutes with you. Anything else you want to ask? Obviously, you're going to want to go back through these couple of questions and try them again on your own to make sure that you are comfortable resolving forces that we don't normally resolve into components, and then using your Newton's laws equations, first law, second law equation, and simultaneous equations with the algebra. Okay, make sure you're comfortable doing that. That's a requirement of this course, being able to do all that algebraic manipulation, lots of it, lots and lots and lots of it. For some of you, that's harder than the calculus. That was always my thing too. Calculus, I was like, I can do derivatives and integrals, no problem. Once you know how to do them, you know how to do them. It's not hard. It's just a different way of thinking. The algebra, you got to get really good at. So even though you may not have liked it in Algebra 1 or Algebra 2, guess what? You got no choice now. You got to get good at it. So practice, 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 practice. All right. The only remaining assignment we have here for Chapter 4 and 5 are the videos. Let me tell you now, your test on Chapters 4 and 5 will be Monday and Wednesday next week. Tuesday, we don't have school. It's a federal holiday, Veterans Day. So Monday and Wednesday, we'll be taking that 2-part test. It's 2 chapters. So part 1, multiple choice, just like the last one, which was 20 multiple choice, and then part 2 the other day. So you get to make your cheat sheet so you can start working on that. Everything else I'm giving you is review stuff. So you've got the videos to help you review for the test, which I'd like you to have watched by Friday. In AP Classroom is a review assignment with multiple choice questions to give you lots of feedback to see how you're doing on those. Plus, there's a bunch of documents I've pushed out, PDFs with solutions, answers, final answers to questions for both multiple choice and free response So you can give those a try as well to help you prepare for Monday and Wednesday's test next week. Okay. Tomorrow we're working on the lab and Friday as well. That's all we're doing in class tomorrow and Friday is working on the lab, the drag force lab. Because once you have data and you've evaluated another group's procedure, we're going to talk about what you have to do to figure out whether the drag force on that filter is proportional to speed or speed squared. So we have a discussion we need to have as a class as to how can you figure out which way it's proportional. Okay? Have a great day, folks.